Hello and welcome to this video on a common cooking misconception. Adding salt to water will make it boil faster. If you've watched cooking shows, listened to a parent cooking pasta and more, you will have heard that you must add salt to the water. Sometimes you hear that this is done for flavour. In other cases, it is done to make the water boil faster. The latter reason is painfully wrong, at least in terms of cooking. Let's start with two simple facts. Water is a liquid and salt is a solid. To make something go from a solid state to a liquid state, you must add energy. These 2 points are established facts and are fundamentally undeniable. At a very basic level, solids become liquids and then gases as you introduce more energy. When a solid object is in a liquid, it will act, at least in part, as a heat sink. The heat or energy begins to add or affect the solid by heating it up to a point. Eventually, it will reach an equilibrium where the heat entering the solid is equal to the amount being dissipated into the water. This will continue to happen as the water rises in temperature, and eventually, if circumstances allow, the solid will transition to a liquid. If it does not happen, it means the liquid will continue to heat up more and more until it transitions. That means that the transformation can occur either before or after it transitions from a solid to a liquid or gas. Water boils when the molecules that make it up are able to overcome the vapor pressure of the surrounding air, and this allows the water to move from a liquid to a gas phase, generally speaking at 100 degrees Celsius. This brings us to what happens when you put water in a pot and add salt. The salt is made up of 2 elements. Each one is an ion in water. First we have sodium and then chlorine. Together they make sodium chloride. What is at least somewhat important and unique about salt is that in water, the sodium and chlorine will dissociate. That is, split and be just sodium and chlorine as separate molecules. This is one reason why seawater is somewhat unique and different from tap water. This is a result of the way the water molecules made from the 2 hydrogens and an oxygen behave and interact. The structure causes the sodium chloride to be unable to retain the connection between the sodium and chlorine. In the end, you have water, sodium, and chlorine as a solution. This brings us to what happens when you start to heat the water. We have, largely speaking, 3 factors that will affect the time and to some extent temperature at which the water boils. We have the presence of salt, the density of water, and the heat capacity. It is also worth noting that water itself has some weird anomalies as you introduce heat, but they're covered somewhat in another video. First, we have a relationship between these 3 things. Density is how much salt is dissolved in your water. The more salt dissolved, the higher the density, and so the higher the heat capacity, because there is more solids in the water. This is because the salt can arguably more readily dissolve in the water as the water gets hotter. Therefore, the water has more density as you warm it up on your stove, in the kettle, or however you wish to heat your water. This means that you have more salt, therefore more density, and because it's more dense and has more solids in it, there is a greater heat capacity. This brings us to what happens to the water itself. Water, or dihydrogen monoxide, is a dipole. Dipole is a fancy way of saying it has a positive charge. This is, generally speaking, going to be the hydrogen side, and a negative charge, which is going to be the oxygen side. When you have sodium is somewhat positively charged, and will therefore be attracted to the oxygen side, which has a negative charge, basically opposites attract. On the other hand, you have the chloride ions, which will be attracted to the hydrogen side, the same fundamental reason. And this is one of the reasons why they separate into 2 distinct ions within water. Because of this, you actually need to put more energy into it to be able to effectively break through the vapor phase, because of these ions trying to hold on to the water molecule. They're basically extra weight. Next we have the density issue, and this brings us back to what we mentioned earlier. As heat goes up, more salt can be dissolved in the water, greater density. Because the density goes up, you now need to think about the relationship between the solutes in the solution and the volume. Generally speaking, the greater the density, the greater the heat capacity, at least to some extent. It's to some extent as all things have a certain heat capacity. This is the earlier mentioned phenomena where an object can be heated up to a point, but beyond that it will emit the excess heat back out into the environment. The same is true of salt in cooking water. You don't just heat the water, but the salt that's a constituent of your cooking water too. So you gradually heat the water, and as the heat in the water in the pot spreads, it goes across the water, and that is all of the water. It basically spreads out. While the water heats, it also transmits that heat energy into the salt, which creates areas where the water is cooler, or at least heats slower, as the heat in those areas is trying to travel into the salt. In those cases, the salt acts as a limiting factor. The water can only get as hot as the salt is to some extent. That means the water can only heat up at the same rate as the salt and will only do so once it is saturated or at a lower temperature than the salt is, because the salt will act as a heat sink, taking in and to an extent holding on to that heat. When you dissolve the salt in water, as mentioned earlier, it will break into sodium and chloride ions, and theoretically, if you were to boil away all the water, those ions would come back together and form salt once more. But you don't need to worry about being able to boil off the sodium chloride. Its boiling point is about 1400 degrees Celsius, which is about 2,500 degrees freedom units. Therefore, there's an incredibly high boiling point of salt, which is why the water will boil before it does. This brings us to an interesting phenomena, and it's why water, and particularly salt water, is kind of quirky. Arguably, the heat capacity is not necessarily altered by the presence of salt, rather it is the conductivity of that heat capacity that is altered. To some extent, salt water is a better conductor of heat by about 1 degree Celsius. That means, theoretically, if you were to add enough salt, you would lower the heat capacity. But there's a big catch to this, and that comes down to the quantity of salt that is required. The amount of salt required to alter the heat capacity in those terms means you need about 20% salt by volume or by weight. Water volume and weight, at least at room temperature, being relatively commensurate with each other. If you add adequate, let's say, salt to water, you would be lowering the boiling point. The approximate ratio, let's say, is that for every 58 grams or so of salt you add to water, it will increase the boiling point by about half a degree. So rather than being 100 degrees Celsius, it would be 100.5, which is a tiny amount. Understand, this would also theoretically improve the conductivity. However, it's incredibly unlikely that anybody is adding nearly 60 grams or about 2 ounces of salt to their water. This brings us to the practical and realistic amounts. As mentioned, all of this is premised on the idea that you're undergoing normal cooking and not crazy amounts of salt cooking. Because of this, the amount of heat and therefore the amount of energy you need to introduce is going to be lower in this case for salt water than it is for fresh water. And this is down to the simple fact that, well, you're not adding enough salt to get the purported benefits. And as a result, when you have salt in cooking water, it actually increases the boiling temperature, albeit not by very much. If you were to add a teaspoon, you may not even notice unless you had very, very accurate measuring devices. If you were to add a little bit more, you might be able to detect it with a good thermometer, as it's going to raise the boiling point of water by about 0.05 degrees Celsius if you were to add 20 grams of salt to a reasonably standard sized pot of water, about 5 liters. So no, adding salt will not make your water boil faster. In fact, it's arguably slower. slower only because the quantity of salt is not enough to improve the conductivity to an adequate extent to make up for the increased heat at which the water itself will therefore boil. Thank you for watching this video. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.